Okay, for adding and subtracting numbers in scientific notation, the ultimate goal here is that we're going to essentially add and subtract them without putting them into standard notation. But I think to understand what's going on first, it's important that we see what it looks like in standard form. So this top number here, 3.8 times 10 to the 7th power, is actually going to be a 3 and 8. So we're going to move it once and then 6 more times, so with 6 zeros here. So this is essentially 38 million, okay? And then this one, it's got the same power of 10 here. And really, you can only add and subtract numbers that are in this form, these forms, if they have the same power of 10. So we'll get to that a little more in depth in a few minutes. But so this one, if I were to move this decimal over once and then 6 more spaces, I get 92 million. So then if we go and add those two numbers up, we get, those are zeros, and then that's 10, and that would be 13. So put in our commas here. 38 million plus 92 million is 130 million. That makes sense. So let's take a look at what happens over here if we add these together. So these powers of 10 essentially indicate the place value of these numbers. So this 10 to the 7th power with a 3, that's 30 million. And then with the 8, so 38 million. 10 to the 7th power with the 9, that's 90 million. So these are in the 10 millionths place, millions place. So we are actually allowed to add these up now. Since they both have the same power of 10, these first numbers have the same place value, we can go ahead and add those. And when we do 8 plus 2, get a 0, throw 1 there, gives us 13. So we're going to get 13 there. And with adding and subtracting, just like when you add and subtract fractions, you don't change the denominator. When you add and subtract scientific notation numbers, you do not change this power of 10 when you're adding. So this is still times 10 to the 7th power, which would make sense over here with the answer that we got. See, 130 million. If I were to move this decimal point once and then 6 more times, I would also get 130 million. But we're going to try and learn how to do all these without this standard notation way of looking at it. I just want to use the standard notation so you can kind of understand what we're doing over here. So now, before I submit my answer, I've got to look at this and go, oh, okay, wait, is this in scientific notation? And hopefully you can see that no, it's not. That number right there needs to be 1 through 9, not a 13. So we're going to move this over and make it 1.3. This is getting smaller by a power of 10, so that needs to get bigger by a power of 10, so that's 10 to the 8th power. I'm going to add 1. If you want to write the plus 1 in there, you can. So we now get 1.3 times 10 to the 8th power. All right, so let's look at another one. Two scientific notation numbers, but they're going to have different powers of 10, and how do we handle that? So I'm going to show you that here. So let's go with, say, 3.04 times 10 to the 5th power, and let's go with 5.1 times 10 to the 6th power. Okay, so the first thing we're going to add those together. The first thing you need to understand is that we are not allowed to add these together as is with just adding these numbers up and lining up the decimals and adding everything. We can't do that. And it might be helpful just to do this once and just kind of look at it and see why we can't do that. See, if we were to put this into standard form, you have to move this decimal point 1, 2, and then 3 more spaces. So this is going to be 3, 0, 4, and then 3 more zeros. So this is 304,000. Well, what's this one? So 5 times 10 to the 6th power, you guys might know 10 to the 6th power is a million. So 5 times a million is 5 million. So if we move this decimal point over once and then 5 more spaces, it's going to be a 5, a 1, and then 5 zeros. So now when we look at this, this is 300,000 essentially plus 5 million. And you wouldn't add the 3 and the 5 together because they would be in the wrong place value. So you have to line up the decimal points from this side over here. So 0 and 0, 0 and 0, 0 and 0. So it's not very neat. 4, 0, 4, 5. So we essentially get 5,404,000 as our answer. So now, what do we do with these numbers if I'm not wanting to, change them completely like this, add them up, and then have to put it completely back into scientific notation? Is there a little in between? And yes, there is. For me, the main rule of thumb is to think of it this way. Take the number that has the smaller power of 10 and rewrite it so that it has the same power of 10 as the one with the larger power of 10. So 10 to the 6th power. So what we're going to do here is we're going to make this top number be something multiplied times 10 to the 6th power. Now it'll take it slightly out of scientific notation, but it's going to make it possible for us to add these two together. So as I take this here, I want to make this, let's just see here. I'm going to go ahead and write this number way over here so you can kind of see what I'm doing. This is my little standard notation just to kind of see how it works. So I'm going to take this number, I'm going to make it times 10 to the 6th power. Well, what happens to this? If this got bigger by a power of 10, what has to happen with this one? Yes, it's got to get smaller by a power of 10. So like that, then move the decimal point over there. So this becomes 0.304. Now it's times 10 to the 6th power, and now I can take my 5.1 and add it to it, times 10. So these are now both times 10 to the 6th power. And as we add these up, remember you don't add their powers of 10, so it's still going to be times 10 to the 6th power, but you do add the decimal numbers. So this is 4, this is 0, this is 4, and then that's 5. So we get 5.404 times 10 to the 6th power. By doing it the way that I did, by making the small power of 10 like the larger power of 10, you will rarely have to change your final answer here back into scientific notation. Okay, it'll usually, once in a while you have to change it, but usually it'll stay as a power of 10 like this, or a scientific notation number like this. So we've got, that's 1 through 9, 5 is in the 1 through 9 category, and that's a power of 10, so this is our answer for adding those two scientific notation numbers. Okay, let's take a look at subtracting. Same rules apply for subtracting as adding, so there's really nothing new to learn there. But let me go ahead and come up with an example. Let's say we've got 8.3 times 10 to the, let's make a negative power of 10 because those can be trickier for some people. So let's go with negative 11th power, and then let's go with minus 6.2 times 10 to the negative, let's go with negative 10th. Okay, so now we can't subtract these because they have different powers of 10. So what I have to do is I have to change the one with that's got the smaller power of 10 to be like the one with the bigger power of 10. And in that case, this is the small one, this is the big one. Even though that's 11, that's a 10. When we're talking negative exponents, negative 11 is smaller than negative 10. So we're going to change this one to look like this one. So I'm going to rewrite this number over here. It's going to be times 10 to the negative 10th power. So that got bigger by a power of 10. So this one needs to get smaller by a power of 10. And so we're going to go right over there. So this is going to become 0.83. And now I'm going to subtract 6.2 times 10 to the negative 10th power. So one little bummer here about this one is that I gave us, by making this the bigger one, I gave us one that's going to come out with a negative answer. That has nothing to do with the power of 10 though. The power of 10 will just stay the same here. So 10 to the negative 10th and 10 to the negative 10th is still times 10 to the negative 10th here. And then when we do this one here, it's okay if you get out a calculator to do that, or first off, you just didn't realize it's going to come out negative, and then you could do 6.2 minus 0.83. it'll end up giving you 5.37. So our number is negative 5.37 times 10 to the negative 10th power, and that is how you add and subtract scientific notation numbers. Always double checking, this one is, always double checking that the answer you give back is still in scientific notation. All right, thanks guys. And again, I'm sorry these aren't thrilling. Hopefully this made sense. If you have any questions, please send me an email or bring them to our Zoom meeting and we can talk about it there. But if you need to rewind this, go over it more slowly, that's one of the nice things about having it on video. Okay,